Hello class, welcome to lesson 4.5, which is all about scatter plots and lines of fit. By the end of this lesson, you should be able to investigate relationships between quantities by using points on scatter plots, and you should be able to use lines of fit to make and evaluate predictions. So let's talk about some new vocab. A scatter plot should be a review, but just in case you forgot what it is, it looks like what you see at the bottom there. It shows a relationship between a set of data with two variables and is graphed as ordered pairs on a coordinate plane. So all of those dots you typically pull from an XY table, and then you plot them. You don't connect all of them, okay? This is not a gigantic connect the dots. It's plot the dots, okay? A line of fit and a trend line is when you model the trend of the data, and I'm going to show you how to find that later on. But something that you want to make sure you take a screenshot of or make sure you memorize is the positive correlation. Let's make a connection to what we've already learned. That looks the same as positive slope, except instead of a line, it's a bunch of dots that kind of make the shape of a line. Same with negative correlation. It makes like a negative slope, but without the line. It's all the points. And then no correlation is when it doesn't look like there's any rhyme or reason for where all of the dots are, okay? So positive correlation looks like our positive slope. Negative correlation looks like our negative slope. And no correlation means that doesn't look like anything, really. Just a bunch of dots. So let's look at our first example. We want to refer to the graph on international travel. And we want to determine whether the graph shows a positive, negative, or no correlation. If there's a positive or negative correlation, describe its meaning. So let's look at the international travel graph on our right-hand side. We see that X represents the years because remember, years are always going to be your X variable because it's independent. And then on our y-axis, we have travelers in thousands, okay? Travelers in thousands. So if we look at all of the dots, they are bunched pretty closely together, and it looks like they match our, let's look back at our concept summary. I'd say that matches our positive correlation. It kind of looks like our positive slope if I were to draw a line through most of the dots. So that means this is a positive correlation. And then if I go back to the directions, it says if there's a positive or negative, okay, so we have a positive correlation, we need to describe its meaning. So let's look. What's happening in our X? Our years are increasing. We go from 1985 up to 2010. And as our years are increasing, our Y values are also increasing, right? We're going from 40,000 travelers all the way up to 65,000. So as the years go on, this graph shows us that more and more people are traveling, okay? So you need to write a sentence like that, okay? Whenever I ask if there's positive and negative and describe, you need to write that. All right, go ahead and try this first example on your own, see how you do. Hopefully you decided that this graph also shows a positive correlation. With each year, the number of mail order prescriptions has increased. All right, so key concept, another thing for you to take a screenshot of and tuck away into your tech screen or your math screenshots folder. Okay, so we have our first step is to make a scatter plot. Determine whether any relationship exists in the data. So that means you're going to take a table of values, you're going to plot them on the graph, and then you're going to look, is it positive correlation, negative correlation, or no correlation? Your second step is going to be to draw a line that seems to pass close to most of the data points. Step 3 is to use 2 points on the line of fit to write an equation for the line. And step 4 is use the line of fit to make predictions. Okay, so let's try that. We have the table shows the dollar value in millions for the sales of CDs for the year. Make a scatter plot and determine what relationship exists, if any. Okay, so let's start by plotting these points. I see I have an XY table. The year is always going to be my X value. And just to save time, I did 0 to represent 2000, 2 to represent 2002. Okay, so it's the number of years since 2000, basically, is what I did there. And then my y-axis is sales. And remember, when it comes to making graphs, you need to label your x and y axis and give your table a name. So let's name this CD sales. If you are missing these labels, you're going to lose some points on your test and quiz, okay? Or actually on your test for this chapter. So in 2000, we were at 13,215. So that's going to be right about there. 2001 was at 12,909. So that'd be right in there. 2002 was 12,044. So basically on that point there. 2003, oops, I did not go far enough for that. So let's try that again. And then 2003 was 11,233. 2004, 11,447, so it went back up a little bit. 2005 was 10,520, 10,520. So those dots represent my scatter plot. What relationship exists among these points? This would be a negative correlation. So a negative correlation, and then I also want to practice some of those skills that I saw on the last slide. So I've done step 1. I made a scatter plot and I determined whether any relationship exists in the data. Now I want to draw a line that seems to pass close to most of the data points. Okay, so a line that goes through most of the data points. So I just drew that line and it would keep going. So there's my drawing a line. Step 3, use 2 points on the line of fit to write an equation for the line. So what 2 points can I use? I used my 2000 and 13,215. And I ended up going through my last point as well. So 2005 and 10,520. Okay, so I have 2 points. Now, what do I want to do? I want to use the 2 points of the line of fit to write an equation for the line. Okay, so let's write something in y equals mx plus b form. So first I need to find my slope. Let's see. If I take 10,520 minus 13,215, and then I can put my 10,520 goes with my 2005 over my 2000. So that equals negative 2,695 divided by 5, or my slope equals negative 539. So that means my equation is y equals negative 539 x, and then I need my y-intercept, which I can either plug a point back in to solve for, or I can look, where does it hit my y-axis? That was at 13,215. So I now have my equation, and use the line of fit to make predictions. We'll do that in our next example, okay? But what I want you to do is test your knowledge of what I just taught you and see how you can do. Hopefully for this first one you determine that there is a positive correlation between the 2 variables. Go ahead and look at the graphs and see if you can figure out which one has the line of best fit for the scatter plot. Remember, your line, You want it to go through as many points as possible. Hopefully you looked at graph B and you decided that one looked like the line of best fit. Using the graph on this last one, along with these points from that first problem, write the slope-intercept form of an equation for the line of best fit. Hopefully you got y equals 8x plus 1,104. Alright, our last example. Use the equation for the line of fit in the last example to estimate CD sales in 2015. So, if we look, our equation was y equals negative 539, x plus 13,215. Alright, now we want to estimate CD sales in 2015. So if we think back to our graph from example 2, remember on the x-axis I counted my years by 0, 1, 2, 3, 4. And I said that it was the number of years since 2000, the number of years since we started with the graph. We're going to use that idea. Instead of plugging in thousands, we're going to use these numbers. How many years has it been since 2015? So we're going to say y equals negative 539. Then how many years have passed if we started at 2000 and we're at 2015? 15 years have passed, plus, and then our y-intercept. So if we plug that in, and we do negative 539 times 15 plus 13,215, we get 5,130. And so our answer is, you can expect that there will be 5,130, not dollars, CD sales that occur in 2015. Alright, go ahead and use the equation from the last example that you did, in it's listed here again, in order to determine or to predict the number of bachelor's degrees that will be received in 2015. Hopefully you said the answer was 1,320,000 bachelor's degrees that will be received. Alright, if you have any questions on this assignment or this video, please be sure to ask for help and I'd be more than willing to help you. Have a great day.